Good morning. Today, let's start with the last topic of the Chapter 14 Factorization. So, the topic is finding and correcting the common errors. Now, to avoid common errors, we should be careful while solving the sums. Means, when we are solving the sums, we should take care that we are not making common errors which generally students make. So for that we first find and then correct the common errors. For this we have to keep in mind some points. So let us see these points. First, coefficient 1 of a term is usually not shown, but while adding like terms, we include it in the sum. For example, suppose if we are writing 3y square plus y square. Yes. Now here you can see that generally we write it as 3y raised to 4, something else. But this is wrong. Here actually both are like terms and no coefficient is shown in with y square, so it is 1. Here 1 is to be counted, so we add both the coefficients of the like terms and it will become 3 plus 1, that is 4y square. So this common error which is made by us should be kept in mind. Next point, remember to make use of brackets while substituting a negative value. Now suppose we want to find out the value of the given expression by substituting the value of given variable. Suppose that in the expression x cube plus x square, this is square, minus x plus 4 equal to 0. In this expression, suppose we want to substitute the value of x equal to minus 1. Now this negative value, when we are substituting in the given algebraic equation, then we have to mention this minus value in bracket. Means we will write minus 1 whole raised to cube plus minus 1 whole raised to square minus 1 plus 4. Yes, this you have to represent in this way so that you don't make mistake while solving further. Now base negative and power is odd, so we'll get minus 1 only here, so we write minus 1. Again base negative, even power we will get positive, so we'll write plus 1. Now again this minus will become plus 1. So these common mistakes, to avoid these mistakes, we have to insert the value of given variable if it is negative in a bracket. Next point, remember when you multiply the expression enclosed in a bracket by a constant or a variable outside each term of the expression has to be multiplied by the constant or the variable. Now here also, let's take an example and see 2x into x plus 5. Now you can see that 2x is outside the bracket and x plus 5 is inside the bracket. So when we are doing the multiplication of this, we have to multiply 2x with x first, and then we have to multiply by 2x with 5. So we will get the answer as 2x square plus 2 5s are 10 and x as it is. Yes. So when you multiply the expression enclosed in a bracket by a constant or a variable outside, each term of the expression has to be multiplied by the constant or the variable. You don't have to only multiply the first term of the bracket with the outside value. Next, remember, for squaring a monomial, the numerical coefficient and each factor must be squared. Generally, students make a mistake here. Suppose we have to square 4pq whole square. Then students write either 16pq square, or they may write 4p square q square. They forget to square each and every part of the given monomial, but these both are wrong. The right answer is you have to square 14 also, you have to square p also, and you have to square q also. So we will get 16p square q square. Yes. So for squaring a monomial, the numerical coefficient and each factor must be squared. Each and every factors must be squared separately. Next, make sure before applying any formula whether the formula is really applicable. Now, to solve the sum, first you see the given expression properly, and then make sure that which formula or which identity or which method is applicable to that expression. So you should take care of applying the formula also in perfect way. And the last point, while dividing a polynomial by a monomial, we divide each term of the polynomial in the numerator by the monomial in the denominator. Now for example, suppose we are dividing 3y square minus 2y plus 6 by y. Suppose 2y only. Yes. So generally students cancel this 2y in the numerator and denominator as common. But this is wrong. You cannot cut the term of the given polynomial with the monomial in the denominator directly. This means each and every term of the given polynomial should be separately divided by the monomial of the denominator. That is, we will write 3y square upon 2y plus 2y upon 2y plus 6 upon 2y. This is how you have to divide each term of the polynomial with the monomial. Now keeping in mind all these points, let's solve exercise 14.4. So exercise 14.4, question number 1. Find and correct the errors in the following mathematical statements. Number 1. 4 into x minus 5 equal to 4x minus 5. Now first let's see whether the given statement is correct or incorrect. It is incorrect only, that is sure, then only we have to find the error and correct it. That is, here we have to multiply 4, which is the coefficient which is given outside the bracket, with both the terms given inside the bracket, that is x also and minus 5 also. So we have to multiply 4 by 4x, which we are getting as 4x here. But when we multiply 4 by minus 5, here we should get minus 20, but we are getting 5. So this is wrong. So the given statement is incorrect. The correct statement is 4 into x minus 5 equal to 4x minus 20. That is, 4 is multiplied by x and then 4 is multiplied by minus 20. So we get 4 into x minus 5 equal to 4x minus 20. So question number 2 is x into 3x plus 2 equal to 3x square plus 2. Again you can see that this is incorrect, because here when we multiply x by 3x, we get 3x square. But when we multiply x by 2, we should get 2x. Here x is missing, so it is an incorrect statement, and the correct statement is x into 3x plus 2 equal to 3x square plus 2x. Question number 3. 2x plus 3y equal to 5xy. Again here you can see that these are unlike terms, 2x and 3y. First term is having the variable x and second term is having the variable y. Both are unlike terms, so we cannot add this. Directly you cannot get 5x. Why? Because here 2 plus 3, 5 you cannot add, because variables are different. They are unlike terms. Only we can add, subtract, multiply or divide like terms. So this is, again it is an incorrect statement, and the correct statement is 2x plus 3y equal to 2x plus 3y. Here we cannot add because both are unlike terms. Unlike means both terms are having different variable. Question number 4. X plus 2x plus 3x equal to 5x. Again you can see that here actually 1 is there which is not shown. So this one which is not shown, but you have to count and you have to add it. So we will get 1 plus 2 plus 3 equal to 6x, not 5x. So this is, again it is an incorrect statement, and the correct statement is x plus 2x plus 3x equal to 6x. Number 5. 5y plus 2y plus y minus 7y equal to 0. Again here you can see these all are added. When we are adding, this one should be counted. So we will get 5 plus 2, that is 7, and 7 plus 1, that is 8y. And 8y minus 7y we will get y. Yeah, you can write, yes, because we are not writing the coefficient 1. So we have to write 1. This 0 is wrong. So again it is an incorrect statement, and the correct statement is 5y plus 2y plus y minus 7y equal to y. It should not come 0. Question number 6. 3x plus 2x equal to 5x square. A very common error done by students. That is here, yes, you can see that both terms of the given expression are like terms. So here you can add, but you have to add it, you don't have to multiply it. Here actually 5x square means you have multiplied this variable x with this variable x, so we are getting x square. So this is wrong. We have to add only the coefficients of the given variable and write the variable as it is, means 2 plus 3, that is 5, and x as it is. So it is an incorrect statement, and the correct statement is 3x plus 2x equal to 5x. You don't have to multiply the variable, only you have to add the numerical coefficients of the given like terms variables. 7. 2x whole square plus 4 into 2x plus 7 equal to 2x square plus 8x plus 7. Again a mistake, you can directly see that 2x whole square. Here you are getting 2x square. This is wrong. Here 2x square means you will square 2 also and you will square x also. So we will get 4x square. Each factor should be squared separately. So 2 square, that is 2 2s are 4, and x square, that is x square. So we will get the term as 4x square. So it is an incorrect statement, and the correct statement is 2x whole square plus 4 into 2x plus 7 equal to 4x square plus 8x plus 7. 8 is proper, 4 2s are 8 we will get. So it is 8x and 7 as it is. Question number 8. Again 2x whole square plus 5x equal to 4x plus 5x equal to 9x. Again mistake here, error here, that 2x whole square, which we should get 4x square, but instead of that it is written only 4x. Only 2 is squared, x is not squared. From 2x whole square, the factors are 2 into x whole square. So we will square 2 square into x square. So we will get 4x square. But here you can see we have written only, it is written only 4x. So this is wrong. So it is an incorrect statement, and the correct statement is 2x whole square plus 5x equal to 4x whole square plus 5x. Further you cannot add because both are unlike terms. Though they are having the variable x in both the terms, but one term is having 2 times x and one term is having 1 time x only. Yes, that is square of x is there, and there the power is 1 only. So these are only also unlike terms which we cannot add further. Question number 9. 3x plus whole square equal to 3x square plus 6x plus 4. Here you can see that they have used the identity number 1, that is a plus b whole square equal to a square plus 2ab plus b square. Let's solve. That is, our a is 3x and b is 2, so we will get 3x whole square plus 2 into 3x into 2 plus 2 square. Yes, so we should get actually again 3x, both the factors should be square, so 3 square is 9 and x square is x square plus 2 2s are 4 and 4 3s are 12. So we should get 12x plus 4. Yes, this we should get, but we are getting, here also you can see we are getting 3x square, which is wrong, and here also we are getting 6x, which is wrong. It should be 12x. So it is an incorrect statement, and the correct statement is 3x plus whole square equal to 3x square plus 3x whole square plus 2 into 3x into 2 plus 2 square, that is equal to, again same mistake here, it is seen that it is written 6x, but it will come, this is not 6x, this is 12x. Only to show that these errors we are doing intentionally, I have written 6x. So here you have written 9x square, but see again here you have written 6x, which is wrong. It should come 12x. This is the correct statement. Dear students, please copy all this in your CW with neat and clean handwriting. Remaining part of the exercise, that is remaining questions of the exercise, we will solve in our next session. Thank you.